Hi, everybody. My name is Hari Subramanian. That's a fancy topic, essentially just talking about the set of data infrastructure and data platform tools that we have built at Uber and how, if you're a data scientist or a machine learning engineer at Uber, what kind of tools and workflows are available for you to build out ML-based application, right? A little bit more about me. I'm an engine manager. Previously, I was an engineer, product manager, did a startup. I was at AWS and VMware and before joining Uber. Up until recently, actually, at the time of writing this, the proposal to this talk, I was leading the big data analytics and data, what we call the data science workbench team, and the Spark as a service team. So you can think of it as the Uber internal version of the Databricks unified analytics platform, both with the Spark runtime as well as the notebook service, and a few other teams. I currently took up another role within Uber in what we call our customer obsession engineering team. I'm going to be talking today about the data platforms, but I also will take an example from my new team, which is the customer obsession team, in how that team leverages AI and machine learning tools at Uber to actually build some customer-obsessed workflows or delightful experiences for our customer. So you guys will see a little bit of work from both of my teams. While I hope you can take away something from this talk and apply that in your own organizations in terms of what kind of works for Uber to do AI and ML at scale. The agenda for today is going to be roughly like this. We'll talk about kind of the Uber scale. What does the data platform look like for Uber? What is data science workbench? That'll form a big part of the talk today. So what is the data science and machine learning toolkit if you were working at Uber? We'll pick up a case study. We talked about the customer obsession team and how we kind of solve a particular business problem for Uber using these data tools, and lessons learned and wrap up. Uber's mission is to ignite opportunity by setting the world in motion. That's a very broad and a very impactful statement, right? Our footprint, we are no longer a small startup that we used to be a few years ago. We have global footprint across the globe, several hundreds of cities. We impact the livelihood of millions of driver partners, impact the lives of millions of riders and eaters across the globe, as well as sizable revenues and bookings. So the way we do all of this is by leveraging data at every stage of the game, and we'll talk about some of that. The goal for the data infrastructure and data platform team as Uber is to make every decision at Uber a very data-driven decision. That animation is, I think, of Paris or London and all the trips that are actually happening there. So just from the scale of it, our goal is to make sure that there are so many things that happen both right and wrong in our businesses, and how we can leverage data and how we can enable and democratize data within the company helps all the people that are working for that company, for Uber, make much higher quality decisions as part of their jobs. So how big is our big data? Kind of millions of daily trips are influenced by systems that are leveraging machine learning. We ingest about 2 trillion messages through Kafka every day. We process about 1 million queries, either automated or human submitted, through different query engines, primarily Hive, Vertica, and Presto. And we also have about 150 terabytes of data that are ingested into our big data lake every single day. So what that implies for Uber's data infrastructure is that we are constantly in the edge of the, we leverage open source software significantly, but we are also constantly in the edge of the operational limits of these open source systems, and we are constantly having to enhance them either directly or by building on top of it. And that's one of the reasons why a company like Uber is usually building a lot of our data platforms and infrastructure ourselves, because it makes a lot more sense for us to move faster that way. So the primary goal, as I mentioned earlier, for the data platform team is to democratize data science within Uber. So the way we do that is by building a very comprehensive data stack across Uber that starts with the data sources, where people can produce data from various applications or ingest data from various online databases that are available, into our big data lake. And all that raw data storage is provided by the team. It's either Kafka-based or HDFS-based internally built systems. On top of that, we enable ETL frameworks and data integrity checks to make sure that the data that's landing in the data lake is sane, it is categorized, and it's accessible and usable by users. We also provide model tables, which is commonly accessible by all the business units for the most common use cases at Uber. So it actually is a very efficient way for us to manage those data sets. We also provide self-service ETL tools. So if you're a custom business within Uber, you are able to go and build yourself a custom data set that is specific to your business unit. So there are also self-service ETL tools and frameworks and data dispersal mechanisms that are available at Uber. On top of that, we have business insight BI tools. We have a suite of experimentation platforms that are built. We have data science and machine learning platforms for production, which are used by engineering teams across Uber to build the data experience that they want for their application, be it Uber Eats or Rides or our marketplace teams. They are building, their engineers are building using these tools, data-driven applications. And also on top of that, we have advanced analytics, dashboards, and monitoring. So these insights are directly consumable by non-engineering folks within Uber. So that's also available. So it's a very comprehensive data stack that the team has built up. So where is the role for data science workbench, and what does DSW do? Let me take the example of what happened roughly 2 years ago when I started at Uber. We had this rapid growth phase at Uber, and that came with growing pains. One particular type of pain was that we were onboarding hundreds of data scientists at Uber, kind of in a short span of time, and these were hired into specific business units, or they could be hired into central teams within our data organization, which means that we had to onboard them and give them the set of tools to make them successful. The problem that they faced was that getting started with data at Uber was extremely hard because they were used to specific tools. Some may use Jupyter or RStudio, some may use Python or R for programming, and they all had their own data processing packages that they wanted to bring in, which means that they were typically running them on their laptops. It was not standardized, and it was very hard for them to get access to data, which was many different sources of data at Uber. This meant that this non-standard environment meant that collaboration was extremely difficult to the extent that it was non-existent. When a data scientist moved from one part of the company, that team was using a specific set of tools, to another part, they had to get used to a completely new set of tools. The fact that their local environment for experimentation was different from production meant that things that worked one way in experiments rarely worked in production the same way. And if you go talk to a data scientist, predominantly what you would have heard is that I spend 90% of my time doing ETLs or preparing data, and I don't have enough time to spend on deriving insights and the real work that I want to do. Probably sounds familiar to what you would hear from data scientists at your company if you talk to them. Right? So the mission for the data science workbench team was actually to build a platform that worked for varied users, not just the super technical data science and machine learning folks, but also we have people called our operations teams that work across the globe that are powering the business. These are extremely smart people with MBA degrees, but not necessarily technical. They're not computer scientists. So we also wanted to build something that worked for a large set of users. These users had different infrastructure needs. Like we talked about, they use different tools like Jupyter or RStudio or their IDE of their choice. Some wanted CPUs, some wanted GPUs, some wanted to be in the cloud. So there was a variety of different infrastructure needs that we wanted to accommodate. All of these users wanted a single window access, a single pane of glass experience that brought together all of their tools instead of having to jump through the hoops or jump into different applications to do specific parts of their job. So we wanted a single pane of glass experience. as well as there was a lot of cost and compliance requirements. We wanted to make sure that if we are purchasing licenses, it was efficiently used. We wanted to make sure that the platforms that we are building and enabling for these users is compliant with regimes like GDPR or SOX that were coming our way. We wanted to make sure that when we are providing access to data, it is actually in a secure way, or we can enforce those security constraints in the future. So it was a fair amount of constraints that we wanted to build for. So what started as a web-based application for hosting Jupyter notebooks essentially became a full-blown data science platform. We call it Data Science Workbench. The mission for this team is democratizing data science by enabling access to reliable infrastructure and advanced tooling in a community-driven way. We also wanted to make sure that we provided the set of data scientists a community within this platform to engage and interact with. And it was a single pane of glass experience where they could actually get all of their job done fully within that platform. So this kind of summarizes where we are today. We are a fully hosted platform. With one click, you can get access to a Jupyter or an RStudio IDE. You get pre-baked environments where a Jupyter or RStudio IDE is provisioned inside a container that's completely, you can customize, as well as it's standardized if you want to just stick with a particular build for your entire team. It's highly scalable in terms of the different size of sessions that you can get with different CPU and memory limits for your application needs, as well as you can get CPU or GPU on demand without having to worry about provisioning capacity. So it's delivered as a service to the entire company. Another big weight that the Data Science Workbench lifts off of the users is providing secure access to all internal data sources, making it multi-data center, secure against failures, providing a shared data store for storing all your data and automatically backing up so your work will never go away. So all of those things are actually baked in, and you can get access to our petabyte scale data lake, to Cassandra, to various other data sources right from within Data Science Workbench. Also, the set of users that consume data are far more than the ones that are producing these data sets or producing insights. So this makes it really, the Data Science Workbench platform makes it really easy for you to share your notebooks or share the insights from your notebooks, because you can also embed a lot of the analytics or visualizations inside these notebooks. So it makes it really easy for you to share these with one click with anybody at Uber, obviously within auth and ODZ controls. So you can share your work, get feedback, all within the context of that Jupyter notebook or within the context of a Shiny or a Bokeh dashboard that you're building. We also combined it with really great documentation, which made it easy for hundreds of users to onboard onto this platform in a very self-service manner, and also combined it with great support. And we have seen phenomenal results in terms of both adoption and the set of amazing things that our users have been able to build using Data Science Workbench. We will be talking about some of these use cases, but we were really pleased with the amount of effort that we put in, that the impact that it had on the organization in unlocking the benefits of data was immense. So what are some of the key features of this platform if you are using it? Primarily, it provides interactive workspaces where a data scientist or a data analyst can go in, do data exploration, ad hoc trend analysis, data preparation, model exploration. All of that can be done in the Jupyter or RStudio interface. You can build advanced dashboards, deriving and visualizing rich insights from the data that you're looking at, as well as displaying business metrics and publishing them for viewing and getting feedback from your peers. And the last use case that we kind of chanced upon, which was not planned for, was business process automation. And we'll look at a couple of examples of this today. Essentially, what we found was that the ability for the central engineering teams to cater to the operations team, which actually are spread across the globe, and each city has unique requirements for compliance or the way they do the business or what stage of business they are in. They may be trying to grow their rides, they may be trying to get profitable. So depending on what stage, their needs are very different, and the ability of a central engineering team to cater to all those use cases is very different. So Data Science Workbench was such a flexible platform that allowed them to do a lot of things with the data by automating business processes, by doing small training, by doing data pulls, and a lot of these things were done within the platform and fully hosted as Python applications or Flask applications within Data Science Workbench. We also combined that with a knowledge base, which was kind of the home page of the Data Science Workbench, if you will, where we can feature insights and feature analytics and dashboards and other notebooks within this interface, so it is easily discoverable, as well as you can find work that other teams have done, which could be very similar to what you may be facing today, and you can easily search and find these the knowledge that you want to share. Let's take a brief look at the product architecture. Essentially, when a user logs into Workbench, once they authenticate, they are presented with a single pane of glass from which they can do very many things. They can create or delete sessions. Sessions are nothing but a RStudio or a Jupyter notebook interface, or it's a Shiny or a Bokeh dashboard, and there are many such applications that are hosted within Data Science Workbench. You can then create dashboards and share them. You can also schedule jobs. So if you actually wrote a notebook and you want that notebook to be run every day to recalculate some metric and publish that into a dashboard, it can be set up as a scheduled job. All of this work is actually saved securely in a shared file system. And the most, give me a second, let me make sure my laptop does not die. There you go. All right. So the most important part is actually all the data connectors that are on the right. So this allows any data scientist that comes into Uber instant access to the petabyte scale data lake that we have using Hive or Spark for batch analytics. They can do Vertica, Presto, or Drogon, which is our Spark as a service, to do interactive analytics. It connects them to real-time data sources such as Pinot and Cassandra, and they can access through MySQL. They can also do machine learning at scale on the large compute cluster we have using Spark, MLlib, XGBoost, or they can do TensorFlow-based deep learning. All of that right from within the platform. So the real power of the platform are these data connectors and the compute connectors that have been built at the back end, which gives our data scientists access to the entire data cluster. So let's look at some of the types of problems that the Data Science Workbench solves. Essentially, what we see is that since Uber has a fairly mature data platform outside of DSW, our users think of DSW as a Swiss Army knife. If there is another tool that is not custom built for your purpose, they typically tend to go to Data Science Workbench, whip up a notebook, and start writing code. And that has kind of produced some immense new use cases that we should just go and build a custom tool for at Uber. So let's look at some of these use cases. I think the most predominant one is an advanced data analytics or a complex analytics that a user might do. Typically, the kind of user that you would see doing this is like a data scientist, or we also have increasingly seen the operations ops analysts or people from the ops team leverage DSW for this kind of use case a lot. The animation that you see on the right was actually built by an ops analyst out of the EMEA market. Essentially, what they did was we have these offices called like green light hubs. Essentially, these are the contact points for our driver partners to come to Uber. Maybe they get onboarded. If they have a problem, they talk about it. If they got into a crash or something, they come there to report it. So that is a place for a contact point for our driver partners to come in and engage with Uber. One of the things that the EMEA team did was they had immense data about this driver, and they had a lot of data about the city itself. In this case, it was Paris, where they had great data about what are the fares per hour, what are the busiest times in Paris, and they could then engage with a driver that's coming in and give them custom recommendations on what are their ratings and what can they do about their ratings to improve that. What is the fares per hour that they're getting today, and if they change their driving pattern, what could they earn and how much more they could earn. They could also look at hotspots within the city and say that these are routes that you potentially might not want to take, and these are potentially routes that you might want to take on these times a day. This was a highly interactive dashboard that was built by leveraging like tens of data sources within the company, both specific to the driver, but also general Uber data that we capture. So, and this has had a huge impact on improving the fares per hours for these drivers, as well as just improving their ratings that they get, because they probably are blindsided by certain things that they're doing in their car. Maybe their car is smelly or something, and they're able to fix those things by analyzing the data and surfacing these insights back to the drivers. And particularly, this is something that a central engineering team would never have been able to turn around and quickly respond to. But the fact that we enabled Data Science Workbench and gave it to these really smart MBAs that are running these operations across the globe made them quickly write some Python and build an application that served that use case. Another thing that we often see within Data Science Workbench is one of a business process automation. Essentially, in this case, RepView is the DMV equivalent in Mexico City. And in Mexico City, we have very stringent laws that if a driver is actually, if one of our driver partners is found driving a stolen car, Uber will be hit with significant fines, and it's not a position that we want to be in. So the operation of actually finding these was a heavily manual process and a very error-prone process that the ops team in Mexico City was able to leverage data because RepView already had posted the list of stolen cars, which was fairly real-time. They were able to incorporate that data and also incorporate a lot of risk scores that are from Uber's for the driver, and build out a data science workbench-based automation and incorporated that into the driver onboarding process and made it really fast and really cheap for them to find these anomalies before they happen. Again, this is another great example of how they built an entire RESTful application end-to-end, leveraging data insights captured within our the data platform, unlock those insights for a real business use case. And lastly, the use case that we see a lot is how people do exploratory machine learning, model training, but they also want to do production right from the same interface. We have seen heavy use of machine learning across various businesses within Uber, be it Uber Eats or support. We'll talk about a support use case today. Risk, safety, operations. We have seen tons of machine learning models that have been custom built for specific problems and deployed from Data Science Workbench. So, where does DSW fit into this larger data platform? I mean, Uber has a very mature data platform, as I talked about. So for the engineers that are amongst the audience, you might appreciate kind of the anatomy view of our data platform. We essentially have a HDFS-based data lake on which we have both Yarn and a Mesos-based compute cluster. We have Presto, Hive, and Spark operationalized as a service for the entire team. Essentially, that means that people come and submit their queries, and they're billed internally for the use of their queries. And they don't have to worry about provisioning capacity. They don't have to worry about a data set access and all of that stuff. It's all taken care of for them because it's delivered as a service. We also have query gateway services, which kind of ensure a lot of the compliance things are met. And we have security, efficiency and capacity planning, and chargebacks, really good observability tools and cross data center replication, so we are protected against failures of one data center that it will not take down of all of our analytics platform. On top of this, we have built several platforms, like XP experimentation is a platform. You can think of that as the loose equivalent in the external world is like Optimizely or something, where you can do A/B testing and other things as a platform. We have a whole suite of BI tools that have been developed internally at Uber that our users have access to. We have a production grade ML platform. It's called Michelangelo. It's been externally blogged about. You can go check out the really great Eng blog at Uber. And we also have a very solid suite of tools within our data processing platform for Piper, which is our internal equivalent of Airflow for workflow scheduling. We have a whole bunch of other tools like data catalogs. So in this rich ecosystem of tools, Data Science Workbench has a very unique place that it allows our users to kind of do what many of these other tools are sometimes not able to. So that's a lot of alphabet soup there, but that is what actually you have access to at Uber if you're doing machine learning or AI at scale. For ingestion or dispersal, there are platforms, Hoover and Marmoret. They're both open source, so go check it out. They leverage Spark and Hive. Data preparation, you have Databook and a bunch of tools within Query Builder and Query Runner. For data analytics, you have a suite of BI tools like I talked about. For machine learning and deep learning, you have Michelangelo as well as Data Science Workbench that leverage all of a bunch of open source technologies, as well as for model serving, workflows, exploration, you have, that's the tool set that's available to you if you're at Uber. All right, with that, we will kind of switch over to kind of the last segment of our talk today, which is going to be taking a look at a particular use case. We call it COTA, Customer Obsession Ticketing Assistant. And it's a deep learning model that was developed and deployed with the set of tools that we just talked about at Uber. So what is the challenge that this team was facing? As Uber grows, our ticket volume and support volumes grow. We get millions of tickets from riders, drivers, eaters per week, and thousands of different types of issues that are sometimes categorized, but sometimes they are unique issues. And these are extremely hard as Uber continues to grow and our scale continues to grow. We cannot let our support costs just scale along with that, right? So this is a very important focus area for the company to actually make sure that our customers get excellent support, so they don't have bad experiences. Plus, there is also a good check on the cost of supporting these of resolving these tickets. So we have developed a tool called Bliss. It's a platform called Bliss internally, and Bliss is the Zendesk equivalent, if you will, for Uber, which is very tightly integrated with all of Uber's internal microservices for that talk to various aspects of the business, as well as is deeply embedded within the analytics platform that Uber has built. So it actually is able to be a smart and intelligent support platform. This is the flow this is what the flow looks like if a user comes in and raises a ticket. They would go in their app, pick a flow node, which essentially is a unique type of problem that they're hitting. They would write a message, and this flow is for the traditional email type support, where you're writing an email to Uber and Uber is getting back to you with a response. But I'm just picking this as an example for showcasing this. So they would write a message to Uber. The message would create a contact ticket internally within Bliss. The contact ticket would actually go to a customer service representative who would look at it, and they are able to route that ticket to the corresponding person. They would select a contact type, which would cause that routing. That agent or somebody else would actually look at look up the information about the driver, the rider, all the different parties that are involved in this. Look up the policies for how Uber recommends they handle this case, and they would select an action. And at the end of it, they would write a response, and the response would go back to the user, and round and round you go until it's resolved. The problem is that resolving a ticket is neither cheap nor easy, because there are thousands of types of hierarchy in the selection of a flow node. There are tens of actions that they could potentially do, be it adjusting a fare or give them an appeasement. And there's also thousands of replies that they could potentially give. And essentially what this makes is that these customer service representatives have to be really high judgment individuals all the time, because it's the company's reputation at stake when they are engaging with customers. It's our brand at stake. So this makes it a really hard problem for them to make all these decisions. So the solution was to actually apply data and machine learning to help customers, the customer service agents, by looking at various aspects of the user, the trip, the ticket, as well as the metadata on the ticket, and develop a machine learning model that would then recommend what type of ticket it is, what is the reply, and what is the potential action. They also we're able to develop in multiple languages and customize that for different geographies, as well as incorporate risk and other features into this model to an extent that we are now able to just route our tickets directly to the right agent based on the routing recommendation from COTA. So let's look at how data science workbench plays a big part here. This is a typical machine learning workflow. Essentially, if you're doing ML, you're starting with the problem definition, you're prototyping your work, you're then taking the model that you've developed, productionizing it, and then measuring the success of your model. Eventually, your model degrades, and you go back to defining the problem or prototyping. And this is iterative, but prototyping is also very iterative. You're getting the data using SQL or Spark. You're cleansing the data preparation using Python or in the notebook you're writing. You're training the model typically in a CPU or a GPU, and then you're evaluating the model. You may be happy or not happy with the results, and you again iterate on this loop. And the vision was that data science workbench is a perfect platform for this iterative development. And you can iterate on a model quickly with tweaks to parameters and configuration. You can you have a flexible development environment by writing custom code or leveraging existing modules. You can do data preparation, ETLs, training, all of that within data science workbench. This was a typical workflow for a data scientist. They would do this in a Jupyter notebook. They get access to prepackaged Spark, Keras, all the different ML tools that they have within a Docker container that was provisioned in Data Science Workbench. They can, and essentially what they wanted was APIs, so they could productionize these models into our machine learning ML platform called Michelangelo. They could set these ETLs up by writing code for them and scheduling the notebook as a part of our data workflow management called Piper. And which means that they could develop locally and iterate very fast, but also deploy in a cluster when their model is ready. This is a work in progress. We have done a lot of this already, but there's also work that the teams are continuing to do to integrate this even more with the rest of the platforms. So let's actually take a look at kind of what a pipeline looks like. In this case, the top of this pipeline is the model training infrastructure, and the bottom is the prediction infrastructure. So let's take a deeper look. In this case, what you want to do is take data from the data sources, which are Hive tables. You want to do some transformations. You want to do some fitted transformations to maybe normalize the data. You then want to convert the data into intermediate TF record form. We are leveraging TensorFlow for doing deep learning here. So we want to then copy the data off to another cluster which has access to GPUs. The data scientists then wanted to do a deep learning training and then take the trained model, combine that back with the fitted transformation, and store it back into a model store. And once in the prediction infrastructure, they wanted to write the same code, which worked for both a Spark-based batch prediction, but also for real-time prediction of when a request came in. So they wanted this to be deployed in a prediction infrastructure in Michelangelo, because that already solved that problem for them. So let's see how this model lifecycle was fully managed in Data Science Workbench. This is what the lifecycle looks like. You start with an ETL, or the data scientist would start with an ETL here. They would do the Spark transformations. They would do the data transfer. They would do the training, the deep learning training using TensorFlow. They would merge the models and deploy it. And each of these was like typically a notebook that they would write up, and that's a module that could be reused in another experiment that they're doing. So, for instance, the ETL would look like some ETL logic that they wrote in Python, and then they can then schedule that as a Piper job, which is our internal version of Airflow, and to do the ETLs on a regular basis. This transformations again were scheduled as Python tasks within the Piper infrastructure, and it would schedule a job on a particular frequency to do these transformations. Depending on some upstream event triggering, the ETL being complete in this case is the end condition. The data transfer would leverage a cross data center data copy tool. So they would just write. So it amounts to opening up APIs and thinking about your microservices in a way that they could be programmed from a notebook. But in this case, it would actually trigger a copy job from a cross data center data copy service, which kept data in sync across multiple clusters, protecting it from a data center level failure. And it would use that for copying the data. Again, the fourth step being the deep learning training essentially would prepare a Docker container where it would have the same image that was used for training that model in DSW inside a notebook. It would package that in a Docker container and schedule that using our Mesos-based infrastructure to do deep learning training. And lastly, you'd also merge these models, the deep learning model and the filter transformation that was made earlier, and store it back into a model store which is used at Uber for productionizing machine learning. And finally, the model deployment is an API into Michelangelo, which is our internal machine learning as a service, to take that model and deploy it in production. Essentially, what this gives a data scientist at Uber is the ability to build these data applications very flexibly inside a Jupyter notebook, but leverage all the monitoring and the operational tools that are available for production scenarios built through Piper and Michelangelo and other such services. Obviously, a lot of these systems are internally built at Uber, but there are open source or public equivalents available. I'm happy to kind of talk more or answer questions about any of these. So from a lessons learned perspective, what we learned was that we want to build the tools for experts, which means we want to open up the APIs and keep your systems fairly flexible for extensibility. But you want to design for less technical people. So the ones that are not experts could also leverage the insights from your system. You don't want to stop building at what's known. Definitely empower the people that are in your organization to look for the unknown use cases and surface them back to you, because that will definitely inspire the engineering teams to go build things and phenomenal new experiences for your customers. And lastly, create communities within your company for both data scientists and data-focused people, but also non-data scientists, because at the end of the day, the role of the data infrastructure teams is to democratize data science and help people leverage data. And you would be surprised the wonderful things that non-data scientists can build actually in your company if you provide them the right tools. With that, thank you, and I'll take any questions.
Thank you, Hari. If you have any questions, there is a mic out there. You can go and ask your questions for another 5 minutes.
Yeah, about 5 minutes. Thank you.
Thank you for that presentation. Now that you have the infrastructure and now that you have the tools ready, could you talk about probably the top 3 current challenges you're facing or your data science teams are facing at Uber?
Yeah, that's a good question. So the top 3 data science challenges for the team. I think I may have painted a much rosier picture. Like I said, the vision is for all of these workflows to be fully automated. They are partially automated, I would say. There is still a lot of work for the teams to build in and extend the capabilities of the data science platform into the production platform. So there is still a lot of work going on in connecting those systems. I also see a lot of work going on in the industry, in startups and in the open source space that are actually building things that connect experimentation to production. So that's a common theme that I see externally. It's also a common theme at Uber. We are working on it. We have a great start. We're still working on it. Another thing I would say comes with the first problem, which is as you think about productionizing something that is an experiment, you would quickly get into a situation where you're productionizing on top of a platform that's not built for 4 nines availability or reliability. And we also face that a lot. A lot of that work has been done in the last few months, 6 months, I would say, to make the infrastructure much more robust, so you could both run an experiment as well as move it to production and get different levels of reliability with these 2 different systems. So you would find yourself in that situation if you just open up for production. You're going to say that, hey, I have this dashboard that's just down for multiple days, but it was never built to be up, right? So I would say engineer from the reliability perspective as well, going into this problem. You said top 3. I would say the third thing is just the empathy between a data engineer and a data scientist is constantly at loggerheads. Data scientists always don't like for data engineers to be the blocker, and data engineers always don't like, don't have cycles for experiments that data scientists want to do. So I think the extent to which you can actually help build tools that bridge the gap is I think, a challenge as well. Thanks. Great question.
Thanks for the great presentation. My question is, have you considered using other notebooks other than Jupyter, like Zeppelin?
Yes. Yeah, we have considered other notebook interfaces. Some of our users use it. I mean, so one of the flexibility of the platform addressed to was to allow users to bring in the tools of their choice. So yes, we have considered. The request for Zeppelin has not been strong enough that we have not added it yet. But largely, I also see that there is a lot of momentum behind Jupyter in the industry. So that seems to cater to a lot of use cases that we care about. Thank you.
Thanks for the talk. My question is, I saw all the tools and all the analytics platform was basically based upon data stored in HDFS. So if that is the only and the single source of data that you have, with HDFS slightly the popularity of it going down with time, what is the fallback and how do you wish to scale all these platforms, all that code which is now strictly basically embedded with that kind of storage?
Yeah, it's a great question. Definitely the, what is the future big data store is something that's evolving in the industry, as we all know. Today, HDFS is the foundational technology that powers our big data lake. You also would have seen that we had access to Cassandra and MySQL and Pinot and many other real-time data sources, right? But barring that, HDFS is where most of our big data is stored today. But I think the key to developing something that is not deeply embedded into HDFS is the set of compute services that we have on top of the data, which we have Hive as a service and Spark as a service and Presto as a service. Essentially, those are service contracts that we can always honor, even if underneath the Spark or Presto or Hive, if the storage changes, we can make that a seamless transition for users because we can still have the service contract from the layer above. So a lot of that is just architecting your system in a way that you can do those changes in a piecemeal way. Because I'm pretty sure 5 years from now that picture would look entirely different, but it's the fact that you can piecemeal attack these problems and keep migrating things to the newer technology. Thank you.
Hi, my impression is Uber is mostly not in AWS or any other cloud, so you manage your own data centers. I wonder if that, in contrast to companies like Netflix, who is completely in AWS, I think. So maybe some, differences, complexity there, and also if you can comment on how I know there's a self-driving effort at Uber, which is pretty big, and the different types of data, how is that handled?
Yeah, so excellent question. Let me take the last question first and then the first question last. In terms of, self-driving is very big. We have traditional types of data. We have data from self-driving, which is very different volume and a very different kind. So yes, we do have to build a data infrastructure that is very flexible for different kinds of data that we can ingest. And a lot of that goes back to providing the self-service tools for those individual business teams to build the data sets that they want in the form that they want, right, and to consume it. That's kind of how I think about it, as well as a big part of that is security. There are certain things that the data platform should enforce and mandate that all users of data take care, because security is a prime candidate for that. Like, you want to make sure that you're governing those policies at the infrastructure level. but there are other things that you want to leave more up to the user, right? And that would address the question of how do we deal with different types of data. I think your first question was cloud versus on-prem. I mean, I also have experience working on at cloud infrastructure providers and on-prem, heavily on-prem infrastructure providers such as like VMware. So I can kind of draw on that as well and answer the question. I think largely for very small number of companies in the world, you do have the scale of your hardware footprint is large enough that you can get the same economies of scale that a large infrastructure provider can, and Uber is one of them, right? So there is advantages to doing your own data centers because you also have the scale, and therefore you can customize things very well for yourself. On the flip side, the amount of innovation that actually happens in public cloud is, again, is tremendous. And like you said, there are companies like Netflix and others that are completely in the cloud, and there are advantages to that. And you know, the set of things that you can leverage commonly from the cloud, you know, allows you to move much faster in that space. So it's a fine balance that you would have to strike if you're a company. Like, where do you pick? And you know, we constantly also keep looking at this from an infrastructure cost standpoint and what are the decisions we are making, and are those the right decisions. But yeah, there is no right answer, but there are lots of choices there.
All right, thank you.
Thank you for the presentation, Hari. You mentioned as part of the data platform, you mentioned some abstraction services like Hive as a service and Spark as a service. Can you shed some light on what happens behind the curtains on those and how those work in terms of security, scalability, performance, and all that good stuff?
Absolutely. So essentially, what Hive as a service or Spark as a service provides to our customers is a similar interface to BigQuery, or a similar interface to Spark SQL that the Unified Analytics Service provides in the public cloud. It allows users to talk to a service endpoint and be able to submit queries, and that is the contract, right? And all of the complexity behind making that query run to SLAs, run on time, taking care of failures, and taking care of high availability, taking care of what kind of compute nodes to choose, taking care of where that data should reside, because you can automatically tell the storage layers to move data that is less frequently used to lower cost storage, for instance. All of that flexibility and the features set could be provided by the query as a service. It's true for Hive or Spark or Presto. That's predominantly what all of our interfaces do, that they kind of set the SLAs to the customer at, this is the query, this is the SLA that I want to meet, and this is the cost I want to provide, and then makes the decisions on how to place the query, where to place the query within the service to meet those SLAs.
Do those run on a cluster, or are there containers that you actually leverage to actually do that?
Both. They run in a cluster in a containerized fashion.
Thank you.
Yep.
So yeah, the last one, so that you can have lunch. Thank you again for the nice presentation. I picked up that you mentioned Vertica, Presto, Spark as part of your analytics platforms. I wonder if you can share very briefly what are the different roles they play in your infrastructure.
Excellent question. So one of the things that we believe in at Uber is leveraging the right tool for the right job. Like, you know, as you may imagine, like Vertica and Presto and Spark and Hive, they can all be used for the same job, but they may not be the best tool for that job, right? But we tend to think of Vertica and Presto for more interactive queries because they are much more expensive per query. The per query cost is much more expensive, but they provide the interactive experience where a human being is submitting a query and they are looking for an answer right now, right? As opposed to Hive or Spark, we tend to think of them as like batch processing queries where you're not optimizing for a human being's time, you're optimizing for machine time, you're optimizing for cost and other things. So that's how we have productionized these services, where the query gating services would allow you to choose one of these query engines, and depending on what your use case is, it would either kind of go to a Vertica cluster or a Presto cluster, or it would go to a Spark cluster or a Hive cluster, depending on what SLAs and use cases that users
saying that in general, many queries can be executed on either, say, Vertica or Presto, and you have an infrastructure that can federate for the users, or is it pretty much a human decision that you build this system on this or that?
Yeah, it's a human decision with a lot of help for them to pick the right engine. There have been conversations about how we can automate that and make that decision for them, but we haven't really felt a compelling need to do that yet. But the big part is that they can go create a query, store it, and pick an engine on which they want to which they want to dispatch the query. And that's all in the same interface. It's a single pane of glass where they can do all of that, which helps with the common set of tools that we can build that could go to many different query engines, but then have the different query engines power the actual query.
Thank you very much.
Great. Awesome. Thanks, everybody.